What's up? I'm Vin, and I'm going to go through this Operations with Decimals survival pack, and I'll leave a link to a copy of this pack in the description below. And I also put chapters in this video, so if there's any section that you need more than others, you could just feel free to skip ahead. Section 1, we're doing understanding decimals and place value. And the big idea for this section is that decimals are just another way to write fractions based on powers of 10, and every digit has a value based on where it is. So for the first question here, what we're going to do is write the number 6.482 in expanded form. And if I were going to read this in a different way, I would say 6 and 482 thousandths. So I notice this goes out 3 places after the decimal point, which would put us in the thousandths place. If I went one more than that, then it would be the 10 thousandths, the 100 thousandths, and so on. But 3 decimal places puts us here. So if I'm writing this out, we have 6 ones. So I have 6 times 1. And then plus the 4 is actually in the tenths place right after the decimal. So this would be 4 times 1/10. And then we would have plus the 8 is in the hundredth spot. So we have 8 times 1 over 100. And then plus the 2 is in the thousandths place. So we get 2 times 1 over 1,000. Okay, so this is the actual meaning of each of these digits in the number 6.482, and this would be the expanded form. Question 2, which number is greater, 4.09 or 4.9? So for this question, there's a nice idea that we could use. When we're looking at decimals, we're allowed to add extra zeros at the end of the number as long as we're to the right of the decimal. So what I mean by that is when I'm comparing 4.09 and 4.9, I think of 4.9 as 4.90. So now I look at these numbers and say, okay, they have the same amount of digits to the left and to the right of the decimal place. So now comparing them becomes a bit easier because now in my head, I'm just comparing the 4s are the same. So I just start to ignore those. And then here it's like I'm comparing 9 versus 90. And I know that 90 is the bigger number. So then that tells me originally the 4.9 compared to 4.09, that 4.9 is the greater number. Okay, so this number here, 4.9, is greater than 4.09. All right, and the idea, if we want to turn this into an idea with fractions, when we look at these trailing decimals here, so the 0.09, this piece becomes 9 hundredths. Okay, so if I look at 0.09, just that part is 9 hundredths, whereas this piece, the 0.90 part over here, is 90 hundredths. So when two fractions have the same denominator, the fraction with the bigger numerator is going to be the larger fraction. Okay, so that's how we know here once again that 4.9 is greater than 4.09. Okay, so this is one way to say our answer as an inequality, but if the question is just saying which number is greater, I could also just say that 4.9 is greater and circle it. Question 3, what digit is in the thousandths place in the number 3.7184? So let's go through these numbers one by one. The 3 to the left of the decimal is in the ones place. Okay, so we have this number is in the ones place. Then we have the 7 over here is in the tenths place. Okay, so now we have the values to the right of the decimal. So we have the decimals over here. And then next, the 1 over here is in the hundredths place. Okay, so we write 100 and then THS. Okay, so then next, the 8 over here is in the thousandths place. And then the 4 at the end. So if we look over here, this trailing 4 would be in the 10 thousandths place. Okay, so which of these numbers, the question is asking, is in the thousandths place? We have the 8. Okay, so the 8 is the number we want, and that's our answer. Question 4, write 0.507 in word form. So for this one, what I think about is the place value in this number here. So the first thing that jumps out at me is that we have a 7 in the thousandth place. Okay, so we have a 7 in the thousandths place, which tells me that this number here, first, numerically as a fraction, is 507 thousandths. Okay, so that's how I think of this first, as a fraction. So then when I have to write this in words, I just write what I just said here out. So I have 500. So we have 500 7. So I have 507. And then we have thousandths at the end. So that's 1,000 with a THS at the end. So this would be the word form of 0.507. Question 5, order the numbers from least to greatest. And we have 2.4, 2.04, 2.004, and 2.44. So for this one, a nice strategy you could use is you could rewrite all of these decimals so that they all have the exact same amount of digits to the right of the decimal. So here I look at this first number and I see that we have 2.4, but this number over here, if we look, has 3 digits after the decimal. So I want to write every other number in the list as a 3-digit decimal. So that first number, 2.4, I'm just going to call it 2. And then 400. Okay, so I'm just going to add 2 zeros at the end. And once again, you're allowed to add as many zeros as you want to the end of a number as long as you're to the right of the decimal, and that number will be equivalent. Okay, so that's just an idea that I'm using. Now, the next number here, 2.04, I would write this with an extra 0, so now it has 3 digits to the right of the decimal. And now we have the third number is already fine, is 2.004, and then the last number I would write as 2.440. So now when I have to order this from least to greatest, I'm just looking at the numbers to the right of the decimal. And I see here that we have 004, which I just think of as 4. So we have 4, and then we have 40, and then we have 400, and then we have 440. Those numbers, when I say it that way, are the numbers in order from least to greatest. But now I just make sure I write it out formally with all the numbers included. Okay, so here, the number 2.004 is the smallest. And that one, I'm just going to write in its original form here. That's 2.004. I'm going to write first. So this is the smallest number. So least to greatest means smallest number first. And then just make the numbers go, bigger and bigger as we go from left to right. So I took care of this number, 2.004. And then next we said it was 4 and then 40. So this one here, the 2.040 came from this number next. So you see this was the original number here, 2.04. So I'm going to write it in the exact form that it was originally written. Okay, so now I took care of this number. And then 400 is smaller than 440. So then 2.4 would be the next smallest number. Would be bigger than this number, but smaller than the last number. Okay, so smallest number, second smallest number, third smallest number, and then the last number here is the greatest, is the 2.44. I'm not going to write it as 2.440 because when you're answering questions in math, you want to use the language of the question and write the numbers in their original form. That way there's no chance of you getting things wrong if you write it in terms of the way it was phrased in the question. Okay, so let me just make this a little neater. Here is the list of numbers from least to greatest. Question 6, what is 48.6739 rounded to the nearest hundredth? So for this one, the first thing I look for is the hundredths place. So notice that we have a 7 in the hundredths place. And then when you're rounding, what you want to think of is if you have a digit to the right that is 4 or lower, if you have this, you round down. Okay, so 4 or lower, you round down. And if you get 5 or higher, you round up. Okay, so 4 or lower, round down. 5 or higher, and you round up. So when I look at this, I see, okay, to the right of the hundredths place is a 3, which falls in this category, 4 or lower. So we round down. So I'm going to take this number here, the 48.6739. And once again, so here we have a 4 or lower. So we're going to round this down to just 48.67. And this would give us choice A. But let's say the concept here is not making sense. Like, what is actually happening here? So for the concept, I like to just imagine the number line. Okay, so we imagine the number line. But to be really skilled at rounding and just really understand what's happening, you have to have a really clear idea of the number line in your head. So when we're rounding to the nearest hundredth, we're counting by hundredths. So what I mean by that is, let's say I'm starting at, over here at, let's say, I'll write this so it stands out. Let's say I'm starting here at 48 point, and if we're rounding to the nearest hundredth, let's say I'm at 66 like this, okay? But I'm going to write 6600 just so that it matches what's going on in the question. And then let's say over here, I'm at 48.6700. So see, I'm just bumping up the hundredths place by 1. That's what it means when you're rounding to the nearest hundredth. In a way, you're just counting by hundredths, okay? And then next, I would have here 48.6800, Okay, so notice once again, I'm just bumping up the hundredths place one at a time. So when I think of the number they gave us, 48.6739, 6739 would put us somewhere in this neighborhood. If I went exactly to the halfway point between these two numbers, this would be 48.6750. Okay, and maybe I'll just write it above so it really stands out. So we would have over here, this would be 48 point, we'd have 67 and then 50. Okay, so this is where we would be. So in this question here, when we're talking about the number 48.6739, so let's say 48 point, let me just move this over, 48.6739, you see how this number here is a little bit to the left of the halfway point. Okay, so let me just try to scoop up this here. So 6739 would be about here. Okay, so the number we're dealing with is here, but when we round, we want to see like which hundredth are we closer to? Are we closer to 48.67 or are we closer to 48.68? And we're definitely closer to this one, which is why we're rounding to choice A. Question 7, which list shows the numbers in order from least to greatest? And for this one, I'm just going to go through the answer choices one at a time. And since we're looking for the answer choice that has the numbers in order from least to greatest, we want the numbers to start small and then just increase. So here, choice A, I noticed that we have one number with 3 digits after the decimal. So I'm going to write 4.07 as 4.070. And then we would have 4.700 and then 4.107. And I can already see that this is not going to be the answer. And the reason is these two numbers here. So just imagine you're comparing 700 to 107. So this would be actually, the number is getting smaller from here to here. Okay, so from here to here, we have the number is decreasing. Okay, so there is a decrease in value from 4.700 to 4.107. So that's why A is out. And then let's say we look at choice B. So for choice B, we have a number with 3 digits after the decimal. So I'm going to write 4.070, and then we have 4.107, and then we have 4.170. So this one is looking good. See, the numbers are just getting bigger. We have 70. I just, in my head, say 70, 107, and then 170, because if the 4 is the same in front, then I just go to the next digit to the right to see which number outranks the other in terms of value. So here, this is definitely working so far. And then finally, we end with 4.7, which could be written as 4.700. So this answer choice is already looking good, but let's see why the other answer choices are no good. So for this answer choice, notice we do have a 3-digit decimal here. So, or 3 digits after the decimal. So I'm going to write the first number as 4.700. And then notice right away we have a decrease here. So from the first to second number, there's a decrease, which would not put the numbers in order from least to greatest. So this one is out. And now if I look at the last list here, see how from here to here, from 4.7, which I could write like this as 4.70 to 4.17. So from here to here, this would be a decrease. And we need the numbers to only be going up here. If we're going from least to greatest, that means the list has to increase. So choice D is out, definitely choice B. Question 8, a student incorrectly wrote the number 475 and 36 thousandths in expanded form as shown below. What error did the student make when writing the number in expanded form? And we have to be sure to include the correct number in standard form in our answer, and we have to explain our answer below. So for this one, my thought process is to break the number down that they gave us piece by piece. So here, they told us the student incorrectly wrote this number, 475 and 36 thousandths. The word end here is telling us where the decimal is. All right, so let me just make this neat. So end is telling us where the decimal goes. So we have 475 first, 475, and so the decimal goes here, 36 thousandths. So here, we just have to be very careful. It is tempting just to say 36. But this is a very dangerous bear trap, okay? This would be 36 hundredths because the 36 is ending 2 places after the decimal. If we want 36 thousandths, that means we have to put a 0 as a placeholder and then write our 36. And then notice here that the 6 should land in the thousandths place and the 3 over here, so just color code this, should be in the hundredths place. Okay, so this is how things should go. And then the 0 is actually in the 10th place, once again, as a placeholder for us to make space so we could say 36 thousandths. Okay, so that's a very important detail. And if we look at what this student did, 4 times 100, so the 4 in the hundreds place is good. The 7 in the tens place is good, 7 times 10. And then they also have here, so let's just see, we have a 5 in the ones place, also good. Okay, it's just at the end here, after the decimal values here, or the tenths, hundredths, thousandths place is off. They have a 3 being worth 1/10, which is not the case. The 3 should be in the hundredths place, and the 6 shouldn't be in the hundredths place. It should be in the thousandths place. So the mistake is over here. Okay, so this is, once again, I'll just put this in a different color. This is where the mistake is. So the mistake is over here, but we actually have to explain it. We can't just say, oh, there's the mistake. And they told us to be sure to include the correct number in standard form in our answer. So if I write the standard form is 475. So let me just write this neat. 475 and 36 thousandths is this. So this would be the correct standard form. Okay, so this is standard form here. And if I wrote the correct expanded form, well, I could borrow what the student wrote up to here. So the 4 times 100 plus 7 times 10 plus 5 times 1. This part is good. We have a 4 in the hundreds place, a 7 in the tens place, and a 5 in the ones place, but it's everything after that's a problem. So here we would have a 0 in the tenths place. So it'd be 0 times 1 over 10. And then we'd have plus a 3 in the hundredths place. So the 3 times 1 over 10 is no good. It should be 3 times 1 over 100. And then plus the 6 should be in the thousandths place. So it should be 1 over 1,000 at the end. Okay, so this would be the correct expanded form here. So this one here is the expanded form, but they told us to explain. So when we have to explain, we can't just correct this student's work and write it nice and then move on, because we'll lose points for not following the directions. We have to first identify what error did the student make when writing the number in expanded form. Is they used the wrong place value for the 3 and the 6. So this explanation here is good. We're just going to say that the student used the wrong place value for 3 and 6. And then this extra sentence here is nice, saying that the 3 times 1 over 10 should change to 3 times 1 over 100. And the 6 times 1 over 100 should change to 6 times 1 over 1,000. Section 2, rounding and estimation. The big idea for this section is that rounding is about finding a close number that makes calculations easier, not about finding exact answers. Estimation helps us check whether answers make sense. So for question 1, we want to round 5.386 to the nearest tenth. So what I do here is first I look at the tenths place, and we have a 3 here, and to the right is an 8. So when we have a 5 or higher, we round up. Okay, so 5 or higher, and we're going to round up. Okay, so here, what we're going to have as our final answer is going to be 5.4. Okay, so this would be 5 4/10. Now, the concept for this is, once again, so I'll just draw out that number line one more time, is if I were at, let's say, 5.3, but I'm going to write 5.3 as 5.3 and then 2 zeros. And then 5.4 I'll put over here. And then between them would be, well, exactly in the middle. So just think between 300 and 400 would be 350. That would be right in the middle. And this number, 5.386, is going to be somewhere in this neighborhood over here. Okay, so 5.386 is going to be somewhere in this neighborhood. But when we're rounding to the nearest tenth, we're going to be between these two numbers here. Okay, we're only allowed to count by tenths. So notice how the tenths place here is the only part here that's increasing when we're counting by tenths. So we could have 5.3, then 5.4, and so on. Now, if I just have to erase these trailing zeros at the end, I will, just to show here that, once again, when we're counting by tenths, we are only interested in these numbers here. And notice that 5.386 is closer to 5.4. So that's the close number that we're thinking about. Question 2, we want to round 12.049 to the nearest hundredth. Now, if you have to say this Properly, this would be 12 and 49 thousandths, but we're rounding this to the nearest hundredth. So we look here at the hundredths place is a 4. To the right is a 9, which tells us to round this up. So we would have 12.05. Okay, and this would be our solution to question 2. Question 3, estimate the sum of 8.97 plus 3.21 by rounding each number to the nearest whole number first. So for this one, the first thing we're going to do is round to the nearest whole number first. Okay, so when I look at these numbers here and see that we have 8.97 and 3.21, when we round to the nearest whole number, we look to the left of the decimal and we're looking at the ones place here. So let's say here I have an 8, to the right of the decimal immediately is a 9. So I would round 8.97 up to 9. So I'd have 9 plus, so just make that a little neater, 9 plus. And then for the second number here, so we have a 3 to the left of the decimal. Immediately to the right is a 2, so we would round down to 3. Okay, so we're going to do 9 plus 3, which is equal to 12. And this would be the estimation here of this sum. So we would have an estimation of 12. And this is useful because it tells us what neighborhood our answer should be in. So what's a reasonable answer? Something close to 12. So if I wanted, this is the estimate here, okay? So this is us estimating here. So our estimate is going to be 12. The actual, which I won't circle because that's not what the question is asking for, okay? This is just going to be something we do off to the side. If I were to find the actual sum here, then, and this is what's going to be the theme of a later section, is I would add these two decimals together. And I would have 7 plus 1 is 8, 9 plus 2 is 11, and I carry the 1. 1 plus 8 is 9, 9 plus 3 is 12, and then the decimal just falls down right in place. So 12.18 or 12 and 18 hundredths is the actual, but notice if I round this to the nearest whole number, I still get 12. So this estimate is pretty good. Question 4, we're going to round 0.00875 to the nearest 10,000th. So if we're rounding to the nearest 10,000ths place, then what we have to do is we have to go out to this place over here. Okay, so we have a 0 in the tenths, a 0 in the hundredths, an 8 in the thousandths, and we have a 7 in the 10,000ths. The next place here would be the 100,000ths. So here, if we're rounding to the nearest 10,000ths place, so we're looking at the 7, to the right is a 5, and we would round this up to 88. Okay, so we'd have 0 point, and then we have the two zeros here, and then we have 8, 8. Okay, so the 7 would bump up to 8, and this would be, the correct rounding here of the starting number. Question 5, a marathon is 26.219 miles long, and we want to round this distance to the nearest whole mile. So if we're rounding to the nearest whole mile, that means we're looking at the ones place immediately to the left of the decimal. Okay, so here we have a 6, to the right is a 2, so we're going to round this down to 26. Okay, so we're going to round the distance here to the nearest whole mile. So we could say 26 miles is our solution to question 5. Now, if you're still struggling with these questions, the thought process is when you look to the right here, so we're rounding to the nearest whole number, to the right is a 2. And what I say is when we have a 4 or lower, that tells us to round down. Okay, and the number 2 to the right here falls in that category. 2 is the number 4 or lower, okay? 2 is lower than 4. So that's why, once again, we are rounding down to 26 miles. Question 6, Hank is measuring his chocolate lab moose to see what size dog bed he should buy. The dog's length from nose to tail is 1.086 meters. What is the length rounded to the nearest hundredth of a meter? So here we are rounding to the nearest hundredth of a meter. So we look here at 1.086. In the hundredths place is an 8, and to the right is a 6. And remember, when you have a number when you're rounding that is 5 or higher, this tells us to round up. Okay, so we're going to round up. And in this case here, we round up, we're going to get 1.09 because once again, we are rounding to the nearest hundredth. And notice that the 9 now is falling in the hundredths place. Okay, so we're in the hundredths place here. So choice C, 1.09. Question 7, Hank is measuring food for his dog Moose. The feeding guide on the bag says Moose should get no less than 1.95 cups and no more than 2.35 cups of food per meal. Which of the following amounts should Hank give Moose? So for this question, one concept that helps us out is being able to see all this on the number line. Okay, so I'm just going to draw out a number line and I'm going to just cut it at a certain place. Okay, so I'm going to mark this number line here at 1.95. So we have 1.95 and then 2.35. Okay, and if we reread this, and when you're going through word problems, rereading is a very important thing to do. That gives you a very clear idea of what the question is asking. So Moose should get no less than 1.95 and no more than 2.35 cups of food per meal. So if we can't go less than 1.95 and we can't go more than 2.35, we have to feed Moose an amount of food that falls between 1.95 and 2.35. So now let's look at the answer choices. Let's say Hank wants to give Moose 1.89 cups. Well, 1.89 would be somewhere over here. Okay, so this would be the location of 1.89. But the problem is 1.89 is less than 1.95. And we can't give any less than 1.95 for the dog. So A is out. And now we look next at 2.36. 2.36 is immediately to the right of 2.35. And notice that 2.36 is more than 2.35, and we can't give any more than 2.35. So B is out. And now we look next to, let's say, 2.305. Well, if I put trailing zeros at the end of these numbers, let's say I write 1.95 as 1.950 and this as 2.350, we could see that the 2.305 is going to be less than 2.350. So that number, 2.305, is definitely less than 2.350 because if we look after the 2 in the decimal, 305 is smaller than 350. But it's definitely more than 1.950 because the ones place here is greater than the ones place here. 2 is a bigger number than 1, so this number is automatically greater. Okay, so choice C is looking good, but let's see, why is choice D no good? So for choice D, notice we get 2.41 cups. And 2.41, if I write this with 3 digits after the decimal, would be 2.410. And 2.410 would fall to the right somewhere over here. So this would be the location here of 2.410. Notice the part that gives it away right away is the tenths place. So the 2 is the same in the ones, but then the tenths place here is greater than the tenths place here, which makes choice D no good because 2.41 is more than 2.35, and we can't give any more than 2.35 cups. So definitely choice C. Question 8, in which number does the 7 represent a value that is 1/10 the value of 7 in 58.7? So this question could be very, very tricky. And this is another one of those type of questions that you might have to reread a few times. So here, once again, in which number does the 7 represent a value? So this part is important. Represent a value that is 1/10 the value of 7 in 58.7. So if we just take this piece by piece, this phrase here, the value of 7 in 58.7, this is a 7 in the tenths place. So here I could say that the 7 here is worth 7/10. And if I reread the beginning of the question one more time, in which number does the 7, so in the answer choices, in which number does the 7 represent a value that is 1/10 the value of the 7 here? So we're looking for a 7 in the answer choices that is 1/10 the value of 7/10. And if I want to find one that is 1/10 the value of 7/10, then I just have to multiply 7 over 10 by 1 over 10. Okay, so I'm doing 7 over 10 times 1 over 10. And when I multiply fractions, I do the numerator times numerator over denominator times denominator. So what I'm looking for is an answer choice that has a 7 in the hundredths place. Because once again, this is, if I say this in words, this would be 7 and then hundredths. Okay, so I'm looking for 7 hundredths. And notice this is a 7 in the ones place, so that's out. This is a 7 in the hundredths place, so this is already looking good. The 7 here is in the thousandths place, so no good. 7 in the 10,000ths place, so this is no good. So definitely choice B. Now, if this method didn't make a whole lot of sense, then what I would do is write this out from the first section. 7 times 1 is 7 when we were talking about place value. And then if I do 7 times 10, that gives me 70. If I do 7 times 100, that gives me 7 700, or a 7 in the hundreds place. So the pattern is when I go this way, so when I'm going this way, I'm going times 10. Okay, see, I'm just going times 10 when I'm going down. 7 times 10 is 70. 70 times 10 is 700. If I want to go backwards, though, and go to the decimal places, 7 times 1/10 is 0.7. And then 7 times 1 over 100 is 0.07. So when we were looking at place value earlier, this was the expanded form that we were using, or the technique we were using for the expanded form of, decimal numbers. And this one here would give 0.007. But once again, the trend here, when I'm going down the list, to get from one number to the next, like let's say from 0.7 to 7, I go times 10. And then 7 times 10 brings me here to 70. 70 times 10 brings me to 700. If I want to go backwards, then what's actually happening is I'm dividing by 10. Okay, if I want to move up the list like this, so I'm going up, then I'm dividing by 10. 700 divided by 10 is 70. Divided by 10 again is 7. 7 divided by 10 is 0.7. So I'm dividing by 10, but dividing by 10 is the same thing as multiplying by 1/10. Okay, so I could also say, hey, I want to go backwards. I'm going to multiply by 1/10. So here, when we see the value of 7 and 58.7 is 7/10. So see how this part here, we started out with the 7/10 before we actually answered the question. So the 7/10 is in this row. And if I want to find a 7 that represents a value that is 1/10 of that, well, if I multiply by 1/10, that sends me up to this row where I have 7/100ths, okay? And 7/100ths, that matched up here with choice B where the 7 was in the hundredths place, okay? So if this method here of just multiplying by 1/10 didn't make sense, just look at the trends here and hopefully this makes things clearer. Section 3, adding and subtracting decimals. The big idea for this section is that when we add or subtract decimals, we have to line up the decimal points so each place value adds or subtracts correctly. For question 1, we have 7.5 plus 3.28. And when I'm doing something like this, I like to line things up vertically. So I'm going to write out 7.5, and I'm going to put a trailing 0 at the end. That way, these numbers have the exact same amount of digits after the decimal. So we have 7.50, and we're going to add 3.28. Okay, so we have plus 3.28. And now for this, we just have to go down the line, and I start from the right. I do 0 plus 8 is 8. 5 plus 2 is 7. The decimal is just going to carry down. And then we have 7 plus 3 is 10. Okay, so we're going to write our 10 here. So we're going to have 10 and 78/100ths. So this works out to, once again, just 10.78. And this is our solution. Question 2, we have 14.09 minus 6.7. And for this one, I'm just going to write it out vertically. We have 14.09. And we're subtracting 6.7. So you just want to make sure that when you're doing this, you don't do something like this. Don't write minus 6.7 and have everything lined up incorrectly. What you want to do is line up the decimal point and then just make sure that the ones place, the tens place, the tenths, and the hundredths place are lined up correctly. So when we subtract 6.7, we're just going to write it out like this. Now, what I could do is I could put a 0 here as a placeholder, and this is just going to make sure that we have the same number of digits after the decimal point. So now I just go ahead and start subtracting. I have 9 minus 0 is 9. And then I have 0 minus 7 I can't do, so I have to borrow. So I'm going to borrow from here, and we borrow and make the 4 into a 3, and then we carry a 1 over. And now 10 minus 7 is 3. I bring down the decimal. And now from here, I'm doing 3 minus 6. I can't do that, so I could borrow from here like this and put a 0 and then put a 1. Or I could just think here and say that I'm doing 13 minus 6 is 7. So we get 7.39. Okay, so this is what we're going to get for our solution to question 2. Now, one thing I want to point out here, this is a lot like doing 1,409 minus 670. And when you subtract these two numbers, you get 739. So the technique for subtracting here is exactly the same as long subtraction from earlier in your school career. But just want to point out with the decimals that you just want to make sure the decimal lines up as you're doing this process. So we get 7 and 39/100ths for question 2. Question 3, we have this sum we're going to find. And for this one, we have 0.856, and we're adding 2.34. And for this one, I have 34. I'm going to put an extra 0 at the end so that we have 3 digits after the decimal. So now we just go ahead and add this. We have 6 plus 0 is 6. Then we have 5 plus 4 is 9. 8 plus 3 is 11, so I write my 1 and I carry a 1 up here. I drop down my decimal, and now I have 1 plus 2 is 3, so this works out to 3.196. Or if I wanted to say this in words, this is 3 and 196 thousandths. Question 4, we're subtracting 12 and 4 thousandths and 8 and 56 hundredths. So for this one, let's just write this out. We have 12.004, and we're subtracting 8.56. And for this one, what I want to do is I'm going to put a 0 here, so we have 3 digits after the decimal, and now I could start subtracting. So we have 4 minus 0 is 4. And now we go to do 0 minus 6, and we can't. So we can't borrow from this place over here. We're going to have to borrow from the ones place. So we put a 1 here, and then that bumps this one up here to a 10. And then I have to borrow from this one and turn it into a 9, which brings the 1 over here. So now I could do 10 minus 6 is 4, and then I do 9 minus 5 is 4. Okay, so that's how this one is working out. I throw on my decimal, and then here, I can't do 1 minus 8, but just think of this now as doing 11 minus 8 is 3. So we get 3.444, and that's the same as saying 3 and, let me just make this a little neater, 3 and 444 thousandths. Now, let's say at any point you're, for an example like this, you're like, wait, this was a little bit tricky. I'm unsure how I did this, if I did this right. If you want to check your work, you could take 8.56, okay, and put the extra 0, and just add our solution here, the 3.444. Okay, when you're trying to check your answer to a subtraction problem, you could always add it back and see if it brings you back to the total you started with. Okay, if I think of simpler numbers, like let's say 7 minus 5 is equal to 2, well, I could check that I did this right by doing 5 plus 2, and that works out to 7. So this is definitely something correct that we could say. So this is using fact families from, way back in your schooling career. So now from here, what we could do is when we're adding this, just 0 plus 4 is 4. And then we have 6 plus 4 is 10. We carry the 1. And then 1 plus 5 is 6. 6 plus 4 is 10. So I get my extra 0, carry the 1. Bring down the decimal. 1 plus 8 is 9. And 9 plus 3 is 12. And you see, we'll just make this a little neater. This brings us back to 12.004. So this solution here is definitely checking out. Question 5, a rope is 15.6 meters long. If 7.89 meters are cut off, how much rope is left? So for this one, we just have to associate here the word cut off with subtract. Okay, so we're starting off with some rope here. So just so you could visualize this, we have some rope, and this rope is 15.6 meters long. So the entire thing here is 15.6 meters long. And we're having some of the rope cut off here. We're cutting off 7.89 meters. Okay, so this amount here is being subtracted out. Okay, so this is being cut off, and we want to know how much is left. Okay, so how much rope is left. So we're taking the total here, the 15.6, and let's make that neater. So we have 15. So we have 15.6, and we are subtracting 7.89. Okay, so we just subtract here. And now I just put an extra 0 at the end. And we want to do 0 minus 9, but we can't, so we have to borrow from here. So we're going to borrow and make this into a 5. And then we put the 1 over here. 10 minus 9 is 1. We can't do 5 minus 8, so we have to borrow here and make a 4. And now we're doing 15 minus 8 is 7. We bring down the decimal. And I can't do 4 minus 7. And if I borrow from this 1 and make it a 0, I'm just putting a 1 over here. So I could just do 14 minus 7 is 7. So our solution here, how much rope is left? We're going to say 7.71 meters. Okay, and I'll write the units out here since we were given meters as the unit in the question. So this would be how much rope is left. Question 6, Evan is biking on a path that is 4.8 kilometers long. He has already biked 1.65 kilometers of the path. How many more kilometers does Evan still need to bike to finish the path? So for this one, they tell us in the beginning that the path is 4.8 kilometers long. So this is the total, okay, the total length of the path. And then they tell us here that Evan has already biked. So they told us he already biked 1.65 kilometers. So this is part of his journey. So if we want to know how many more kilometers does Evan still need to bike, so this is the actual question, how many more kilometers, then we're going to take the total and subtract the part that he already biked. So we're going to go 4.8 and then minus 1.65. And for this one here, I want to have a matching amount of digits after the decimal. So I'm going to put a 0 next to the 8. And now from here, I can't do 0 minus 5, but what I'm going to do is borrow. So I'm turning this 8 into a 7, and I'm going to put a 1 over here. So now I could do this and do 10 minus 5 is 5. 7 minus 6 is 1. I bring down the decimal. And then 4 minus 1 is 3. So we get 3.15 kilometers. That's how many kilometers Evan still needs to bike to finish the path. So choice B. Question 7. Aiden has a $20 bill. He buys a notebook for $3.49 and a set of markers for $6.75. How much money does Aiden have left? So for this one, let's find out how much money Aiden is spending in total first. So he's buying a notebook for $3.49 and a set of markers for $6.75. So we're going to add those two numbers together. So we have 3.49 and we're going to add 6.75. Okay, so we have plus 6.75. And now we just make sure everything's lined up nicely. Let me just make this a little neater. So we're going to add first 9 plus 5 is 14 and we carry the 1. And then 1 plus 4 is 5 and 5 plus 7 is 12. So we have a 2, we carry the 1, and then we bring down the decimal. So now we've got 1 plus 3 is 4 and 4 plus 6 is 10. So this tells us that Aiden is going to spend $10.24. So from here, what we do is we subtract this from 20. Okay, so they told us in the beginning that Aiden has a $20 bill. So we're going to take the $20 and subtract the total bill here, the $10.24. Okay, so the total amount he owes, we're going to subtract from 20. So we can't do 0 minus 4. So we're going to move down the line to the 2 and borrow and make this a 1. Now, I could bring it over here and then borrow from this and make this a 9. Or I could just make this a 9 right away and then just make this one here a 9 and then put the 10 at the end like this. Okay, so now I'm doing 10 minus 4 is 6. And then next I'm going to do 9 minus 2 is 7. And then I could bring down the decimal. And then from here, notice we would have 1 minus 1. So I'm not going to write a 0 in the tens place. I'm just going to worry about doing 9 minus 0 is 9. And then this is going to be the difference here, 9.76. And we're talking about money, so this is $9.76, choice B. Question 8, Liam is buying cheese for a family gathering. He buys 0.85 pound of cheddar, 1.27 pounds of mozzarella, and 0.68 pound of Parmesan. How many total pounds of cheese does Liam buy? So for this one, we just have to add these three numbers together because we want to know how many total pounds of cheese does Liam buy. So he's buying 0.85 pound of cheddar and then 1.27 pounds. So we're going to write next 1.27. He's buying that many pounds of mozzarella and then 0.68 pound of Parmesan. Okay, so this is the three types of cheeses that he is getting, and we're going to add these three together. Okay, so we could add 3 at a time. We just have to be careful. So we have 5 plus 7 is 12, and then 12 plus 8 is 20. So we put a 0, and then we carry the 2. And then we have 2 plus 8 is 10, 10 plus 2 is 12, and 12 plus 6 is 18. So we write an 8 and carry the 1 and bring down the decimal. So now we have 1 plus 1 is 2, and this tells us that Liam is buying 2.80 pounds of cheese in total, choice C. Section 4, multiplying and dividing decimals. The big ideas for this section are multiply decimals by ignoring the decimal, then place it using the total decimal digits. And then when we divide decimals, we do this by shifting the divisor to make it a whole number, and then shift the dividend the same amount before dividing. So let's go ahead and go through these examples. Question 1, we're doing 3.4 times 2. So for this one, and this is coming from the big idea, what we could do is we could do 34 times 2. And then after we do 34 times 2, we just have to be mindful here that we're going to shift the decimal by using the total decimal digits. Okay, so when we count the number of total decimal digits here in the original question, there's just 1. So that means I'm going to work this out here and then move the decimal 1 place to the left. So here I'm going to go 2 times 4 is 8. and then 2 times 3 is 6. And this is technically going to give us 68, which I can think of as 68.0. So when I do 3.4 times 2, I'm going to take 68.0 and I'm going to move this decimal one space to the left. And this product here is going to work out to 6.8. Okay, so I could say 3.4 times 2 is equal to 6.8. Now, one thing I want to talk about before I move on to the next example is the concept. Why does this work? Well, when we work this out here, what we're actually doing when we do 3.4 times 2 is we're actually doing, I could call 3.4, this is the same thing as saying 34 over 10. Okay, 34 over 10 is the same thing as 3.4. And when I multiply that by 2, I'm really just doing 34 times 2 and then dividing that quantity by 10. Okay, so once again, I could write my decimal values like this and in fraction form as, let's say in this case here, 34 divided by 10. And then when I multiply by 2, I'm just doing 34 times 2 divided by 10. And that gives us 68 over 10, which once again, I'll just make this a little neater. When we do 68 divided by 10, we're just moving this decimal, just imagine 68.0, and we're just moving that decimal one space to the left. And that's why we're getting 6.8. For question 2, we're doing 0.6 times 0.7. And for this one, this time around, we have 2 digits after the decimal. See, we have 1 here and 1 here. So we could just do 6 times 7 off to the side is 42. But now think of this as 42.0. So when we do 0.6 times 0.7, that's 2 digits after the decimal that we're ignoring here. We just have to move this 2 spaces left to get 0.42. Okay, so this would be the product of 0.6 and 0.7. Another way to see this though, once again, just to highlight the concept of what's actually happening here, what we're doing is we're doing 6/10 times 7/10. And when we do this, we're doing 6 times 7 in the numerator over 10 times 10 in the denominator makes 100. And this gives us 6 times 7 is 42 divided by 100. And I could just say here 42 hundredths equals 0.42. Or if we think of it like this, so just see here, this is 42.0. When we divide by 100, the decimal goes 2 places to the left like this. Okay, so we're going to move it 2 places to the left, giving us 0.42. Okay, so that's just another way of seeing this. So this answer is definitely correct. For question 3, we have 5.03 times 4. Now, I just want to point out for something like this, you could just multiply things normally and just place the decimal using estimation strategies. So when I'm looking at 5.03 times 4, I'm thinking this is roughly equal to 5 times 4. Okay, this is very close to 5. So when I do 5 times 4, I get 20. And since 5.03 is a little more than 5, I know this product above is going to be a little more than 20. So when I multiply this out, 5.03 times 4, and I want to use this estimation strategy, I just work this out normally. So I do 4 times 3 is 12, carry the 1. 4 times 0 is 0, plus 1 is 1. And then we have 4 times 5 is 20. So if I'm thinking here, like, where does the decimal go? Does it go in this place? Does it go in this place? In this one over here? Where could it go? Like I said before, this is very close to 5 times 4, which is 20. So I know the solution 20.12 makes the most sense here. Okay, so I'm going to say 20.12 is our solution. However, if we use the big idea from earlier, notice there are 2 digits after the decimal. So after I multiply this out normally, pretending there's no decimal places, then I just have to say, all right, there's 2 places after the decimal. So I have to move it back 1, 2 like this. Okay, but the estimation strategy is a very nice way to check if your answer makes sense. Okay, that's a very important question to have to, well, that's a very important question to be able to answer in math. Question 4, we're doing 2.75 times 1.2. And for this question, I'm going to use an estimation strategy again. So 2.75, if I round to the nearest whole number, rounds to 3. And then I can multiply that by 1 because 1.2 rounded to the nearest whole number rounds to 1. And 3 times 1 equals 3. So our answer is going to be close to 3. Okay, so that's why I'm thinking of this over here. So now I work this out. I have 275 times 1, 2. So let's say I'm doing 275 times 12. I'm going to pretend there's no decimals here. Well, then I could do 2 times 5 is 10. So I have a 0 and I carry the 1. 2 times 7 is 14, and 14 plus 1 is 15. I carry the 1. And then 2 times 2 is 4, plus 1 is 5. And now I put a placeholder. 1 times 5 is 5. 1 times 7 is 7. 1 times 2 is 2. And I add all of this up. So we get 0 plus 0 is 0. 5 plus 5 is 10. So I have a 0, carry the 1. 1 plus 5 is 6. And 6 plus 7 is 13. Carry the 1. 1 plus 2 is 3. So here, when I'm writing this out, remember, our answer has to be in the neighborhood of 3. It has to be close to 3. So the decimal at the end is going to go over here. So when I write the answer out, we're going to get 3.3. But if we go back to the big idea from earlier, when we're doing 2.75 times 1.2, so when I work this out, and let me just line this up a little bit nicer. So we have 2.75 times 1.2. I multiply this out normally, and I get 3300, but I have to count the number of decimals. I'm sorry, count the number of digits after the decimal. So that's 1, 2, 3. So when I'm placing the decimal at the end, what I'm going to do is I write it as 3300.0, I think of this as, and then I just move the decimal 1, 2, 3 places like this to get 3.3. Okay, so that's the technical way of getting there, but this is just, once again, showing the estimation idea. This is very useful because it helps you answer the question, does my answer make sense? And this skill is very important for you to carry for the rest of math and even across your other subjects and in your life, is being able to say if something makes sense, okay? Just knowing when things are off. So one other idea I want to explore is if we were to turn this into fractions. So what I'm about to show is a little bit extra, but this is just a nice way to see that we could also solve this with fractions if we didn't want to work with decimals. So something like 2.75. So this is the same thing as 4/4 plus 4/4 plus 3/4. Okay, 0.75 is the same thing as 3/4. Just think 3/4 is worth 75 cents. So here I have 4/4 plus 4/4 plus 3/4. And then 1.2, this is the same thing as 12/10, which if I reduce the fraction here, so I divide top and bottom by 2, this would work out to 6/5. So now if I multiply these fractions together, so I'm going to multiply, and let's just simplify this first. 4/4 plus 4/4 is 8/4 plus 3/4 is 11/4. So now we multiply this stuff together. So this is just an alternate way. I take 11/4 and I multiply by 6/5. And now for this one, I could reduce first and then multiply, or just do 11 times 6 is 66 divided by 4 times 5 is 20. And then we reduce our fraction here. So I could divide the numerator and denominator by 2. And I'm going to get over here, we're going to have 33/10, and 33/10 simplifies to 3.3. Okay, so there's more than one way to do this. And when you're learning something new in math, it's always a good idea to try to connect it to something extra. And in this case, we would be connecting it to fractions. Okay, so the fraction decimal connection is something that is going to show up later, but it is cool to see that you can solve problems in more than one way. Question 5, at the plaza, Sophia and her cousins buy 8 churros. Each churro costs $2.49. How much do they pay altogether? So for this one, we're going to take the cost of each churro. So we have $2.49, and we're going to multiply that by 8. So notice this is just an application of multiplying decimals. So here, notice there are 2 digits to the right of the decimal. So we just multiply this normally, but then just know we have to move the decimal at the end 2 spaces to the left. So we do 8 times 9 is 72. We carry the 7, and then we have 8 times 4 is 32, and 32 plus 7 is 39. So we have a 9, carry the 3, and then we do 8 times 2 is 16, plus 3 is 19. And see, those were 2 places that we have to pay back at the end. So the decimal over here is going to move 2 spaces to the left like this. Okay, so our solution here is going to be $19.92, which is choice D. Question 6, we have 9.6 divided by 3. So I'm going to set this up here as a division question with this symbol over here. So we have 9.6 divided by 3. And since our divisor is a whole number, we could just go forward and start dividing here. And the big idea from the beginning of the section, notice that I pointed out that when you have a non-whole number as your divisor, that you want to move the decimal in the divisor until you do have a whole number. So for this one, we could just get started. So I'm going to do 9 divided by 3 first is 3. And then we have 3 times 3 is 9. So we subtract 9, and this works out to 0. And now the decimal, I could just throw up here, and I could bring down the next digit here, the 6. And now I do 6 divided by 3 is 2. I write this after the decimal, and now we have 2 times 3 is 6. We subtract, and we have no remainder. So this tells us that this quotient works out to 3.2. Now, one thing I want to point out here, just to make a connection, is that we could think of this in terms of fractions altogether. So what I want to do here is I'm going to rewrite this question as 9.6 divided by 3. And then I'm going to write this in expanded form above. So this is the same thing as saying 9 plus 6/10, and I'm dividing by 3. And when you have a fraction like this with a sum, you are allowed to break a fraction like this up into 2 pieces. So I could say 9 over 3 plus 6/10 divided by 3. And now if I go piece by piece, so over here, I'm going to say that 9 divided by 3 is equal to 3. Plus, when I do 6/10 divided by 3, think of this as 3 over 1. I could use the technique, so for this next part coming up, so over here, actually I'll just label this piece over here, I'm going to use keep, change, flip. So I'm dividing this fraction here by the fraction 3 over 1, and I'm going to get 6 over 10 times the flip here is 1/3. And now if we cross cancel, I could do 6 divided by 3 is 2. So this gives me 3 plus 2/10, which is the same thing as 3 and 2/10. And 3 and 2/10 as a decimal is 3.2. Same answer. Question 7, we have 24.5 divided by 5. So I'm going to set up this division problem here like this. So we have 24.5 divided by 5. And we want to do 5 going into 2, but 2 is not divisible by 5. So now we look at 24. 24 divided by 5, we could get as close as 4 times 5 is 20. Okay, if we would have put a 5 here, we would have 5 times 5 is 25, which is too much. It goes past 24. So now 24 minus 20 is 4. I put on my decimal here, and then I bring down the 5, and now 45 divided by 5 is 9. And 9 times 5 is 45, and we get no remainder. So this works out nicely to 4.9. Question 8, now we have a question where we're dividing by a decimal. So I'm going to set this up here. We have 7.2 divided by 0.6. And if you recall the big idea from earlier, the idea was to move the decimal as many places as we need to in the divisor until we have a whole number. So notice here, I'm going to go 1 place to the right, and that's going to give me a 6 out front. And then that means I have to go 1 place on the inside as well, which is going to turn this into 72. And now from here, I'm just doing 72 divided by 6 is 12. Okay, this divides evenly, so our answer is actually just going to work out to 12. Now, for this one, I definitely want to point out the concept. Why does this trick work? Why are we able to move 1 here, 1 here? Well, one thing we could do is we could express this as a fraction. So the concept that I'm going to use here is that we could rewrite this question as 7.2 over 0.6. And with fractions, when we have something like, let's say 1/2, if I multiply this fraction by 4 over 4, so 1/2 times 4 over 4 gives us 4 over 8. And this fraction here and this one here, they are equivalent fractions. Okay, so what we're doing here in this part over here is we're going to make equivalent fractions. So I'm just going to multiply by 10 over 10. And I do this because what that's going to do is it's going to turn 0.6 into just 6 on bottom. Okay, so the decimal is going to move 1 place to the right like this. And then when I multiply by 10 on top, I'm going to get 72 on top. And notice I'm getting 72 divided by 6, which is equal to 12. So this moving the decimal trick is really writing this out here, this expression, as a fraction, and then multiplying by a power of 10 until you have a whole number on bottom. Okay, so that's what's going on behind the scenes and why this technique works. Question 9, we have 15.75 divided by 0.45. And for this one, I want to move the decimal 2 spaces to the right. Okay, so I'm going to go 2 places. And that means the decimal here on the inside is going to go 2 places like this. Okay, so we're going to go 2 places to the right, and that's going to transform this question into the following. Okay, this is going to turn into 1,575 divided by 45. And now for this one, this is where things might get a little bit tricky. We can't do 15 divided by 45, but we can do 157 divided by 45. So for this one here, if you could count by 45s, then great. Otherwise, you have to use estimation strategies. So counting by 45s, we get 45, 90, 135, and then 180, which is too far. So I know this is going to be 3 up top, and then 3 times 45 is minus 135 over here. Now, in terms of estimation strategies, I would look at 45. So if I want to use estimation, then I'll just abbreviate like this. I'm just going to do 50. I'm going to start counting by 50s because 45 is very close to 50. And if I count by 50s, notice that I get 50, 100, 150, and that would be the third multiple here in the list. So that's how I know times 3 is reasonable. But the worst that happens is if you multiply by the number and it gets you to be, let's say, past the number you want or way too far behind the number you want, then you just keep trying until you get the nice match here. So now I do 7 minus 5 is 2, 5 minus 3 is 2, so remainder 22. And then I bring down the 5, and 225 divided by 45 is one more past 180. So if I do 180 plus 45, that brings me to 225. And this is times 1, 2, 3, 4, 5. Okay, so we get a 35 here. 5 times 45, once again, is exactly 225. So this divides evenly here, and we're going to get 35 as our solution. Question 10, we have 0.36 divided by 0.75. So for this one, we're going to set this up the same way. So we're doing 0.36 divided by 0.75. So first order of business would be to move the decimal 2 places to the right here and here. So we get this question over here. So we get 36 divided by 75. But for this example, what makes this one a little bit tricky is now the number here on the inside is less than the number on the outside. So when we do this, we want to say 36 divided by 75 is 0, and then we put a decimal. And then what we could do is on the inside, once we do 0 point, we could start throwing zeros in like this. So now I start counting by 75s. And if you have trouble counting by 75s, my advice would be to just play a game like Monopoly and be banker. And when you're being banker, obviously try to do it over time without technology. That's how I got good at mental math and specifically counting by 75s. This was the red and yellow properties. So the red and yellow properties, they count by 150, but 150 is 75 times 2. So if I count by 75s here, I'm going to get 75, 150, 225, and then I get 300. And if I go one more, that would be 375. So I could get as close as 75 times 4. So I put a 4 here and I subtract 300, and now I get a remainder of 60. And then I could just keep adding zeros and bringing this down until everything divides nicely. So now I'm doing 600 divided by 75. Well, if we pay attention to this number in the list over here, notice this was over here, this value was 75 times 4. See, it was 1, 2, 3, 4. So 600 is just double that. So if I double this to times 2 over here, this tells me that 600 is equal to 75 times 4 times 2, which would give me 75 times 8. Okay, so I know that an 8 is going to go over here, and then I do 8 times 75 is 600. I subtract, and now I have no remainder. So this is going to be my decimal answer. I'll just make this a little bit neater. So we have 0.48. But now let's see how we could check our answer. So for this one, what I want to do is I'm going to write 0.36 as 36 hundredths. Okay, so I have 36 over 100 like this. And now I'm dividing by 0.75. This is the same thing as 75 over 100. And that reduces to 3/4 when I divide the top and bottom here by 25. So I'm dividing by 3/4. And then I use keep, change, flip here. So I would have 36 over 100 times 4 over 3. And for this one, what I could do is I could divide 36 by 3. 36 divided by 3 is 12. And now I just do 12 times 4 is 48. And I get 48 over 100, which simplifies to 0.48, which is the exact same value we got over here. So this answer definitely checks out. Question 11, a 9.84 meter ribbon is cut into pieces of 0.12 meters each. How many pieces are there? So for this one, we're starting out with a piece of ribbon that is 9.84 meters long. Okay, so this ribbon over here is, let's say, 9.84 meters long. And we're cutting them into pretty small pieces. Okay, we're cutting this big piece into small pieces. And each small piece here is 0.12 meters. So the question is, how many of these could we cut from the big piece? All right, that's the question here. So what we're doing is we're making groups of 0.12. So we're taking 9.84 and we are dividing it by 0.12. So for this, what we're going to do is we're going to move the decimal 2 spaces to the right for each of these pieces. Okay, if we have to visualize it with the expression over here by doing 9.84 divided by 0.12, we could see we're going to go 1, 2 on the outside, and then we're going to go 1, 2 on the inside. We have to make sure that whatever amount of spaces we move the decimal here, that we match it on the inside. Okay, that's very important. So here, now we're going to set up on the side 984 divided by 12. All right, the answer to this question is going to be the answer to the main question that we want over here, which is what is 9.84 divided by 0.12. So now, and I'm gonna just make a little space over here. So I'll move this back to where it was over here. So now we can start working this out. So I can't do 9 divided by 12, but I can do 98 divided by 12 is 8, and then 8 times 12 is 96. And when we subtract, we have a remainder of 2. And we bring down the last digit, the 4. 24 divided by 12 is 2, and then 2 times 12 is 24, and we get no remainders. So here we work this out, and this works out to 82. And the question is asking, how many pieces are there? I'm just going to write it out formally. I'm going to say there's 82 pieces. Okay, so this is our solution to question 11. Question 12, Ava earns $40.50 for babysitting for 3 hours. At that same rate, how much does Ava earn when babysitting for 2.8 hours? So for this one, we're told in the beginning that Ava earns $40.50 for babysitting for 3 hours. So what we're going to do with this information here, we set up this rate, and this is going to help us find the unit rate, okay, which means how much money Ava earns for 1 hour. Okay, so how many dollars does Ava earn per hour? And for this, what we're going to do on the side is we're going to divide 40.50 by 3. Okay, we're going to divide here. And since we have a whole number as our divisor, we could just start this process. So 4 divided by 3 is 1. And then 1 times 3, let's make this a little neater. 1 times 3 is 3. We subtract, and we get a remainder of 1. And now I bring down the 0 over here. 10 divided by 3 is 3. And then 3 times 3 is 9. We subtract, remainder 1, and we bring down the 5. And now we get 15 divided by 3 is 5. But notice this is where the decimal lines up. So this is going to tell us how much money Ava makes. We throw the decimal up here at this part, and we have 5 times 3 is 15. We subtract, and we have no remainder. And now we can bring down the last 0 and do 0 divided by 3 is 0. 0 times 3 is 0. We subtract, and we have no remainder. So this tells us that Ava is making $13.50. Let me just make this neater. $13.50 per hour. Okay, so this is how much money Ava makes per hour. So if we want to know at this same rate, how much does Ava earn when babysitting for 2.8 hours, we would multiply 13.50 by 2.8. Okay, so we're going to multiply this out. But remember from before with multiplying the decimals together, we want to make sure, and I'll just move this over a little bit like this, that we set up the correct corresponding problem. So there's 1, 2, 3 digits after the decimal. Okay, and I'm just going to move this over so we could set up the correct question right next to it. So we're going to do over here 1,350. And let me just change colors here. So we'll do this. How about we do this in red? So we'll have 1,350 times 28. And if we notice over here, once again, there was 3 digits to the right of the decimal in total. So we have to pay back 3 decimal places. Okay, so 3 decimal places is what we're going to have to pay back at the end. So now let's go ahead and work this out. 8 times 0 is 0. 8 times 5 is 40. So we put a 0, carry the 4. 8 times 3 is 24. 24 plus 4 is 28. Carry the 2. And then 8 times 1 is 8. Plus 2 is 10. And now I put a placeholder here. So I put a 0. 2 times 0 is 0. And then I'm just going to cross these out so they don't confuse us. So we had 2 times 0 is 0 in this place. 2 times 5 is 10. So I put a 0, carry the 1. 2 times 3 is 6. Plus 1 is 7. And then 2 times 1 is 2. we add all of this up. So we have 0 plus 0 in these two places, 8 plus 0, 0 plus 7, 1 plus 2 is 3. And now I write this over here. So I have 3, 7, 8, 0, 0. But once again, I have to pay back 3 decimal places. So I'm going to take this decimal and go 1, 2, 3. And this is going to give us $37.80, choice C. Section 5, we have order of operations with decimals. And the big idea for this section is that we're going to follow the order. Parentheses, multiplication, division, then addition, subtraction, even with decimals. Question 1, we have 4.5 plus 2.1 times 3. And for this question, we're going to use order of operations. So I'm just going to write out here the phrase PEMDAS, which is just a shorthand way of expressing what I said in the big idea earlier. So when I look at this question, I notice that we have multiplication and we have addition. Okay, so we have this over here. So since multiplication shows up first, we're going to do 2.1 times 3 before we add 4.5. So let's go ahead and multiply this out. And another thing to pay attention to is that we have one digit after the decimal. Okay, so I'm just going to do 21 times 3, and then I'll worry about the decimal at the end. So I do 3 times 1 is 3, and then 3 times 2 is 6. And notice there's one decimal place to pay back. So I imagine this says 63.0, and I just move the decimal one space to the left like this. So now I could say that this equation here, I could write out, we're going to have 4.5 plus the product of 2.1 and 3 is 6.3. So now all I have to do is add these numbers together, and I'll do this off to the side. I'm just going to set this up vertically here so we could line up the place values. So we have 4.5 plus 6.3, and we're doing 5 plus 3 is 8. We bring down the decimal, and then 4 plus 6 is 10, so we get 10.8. So our answer to this question here is going to be 10.8. Question 2, we have 6.2 minus 1.8 inside parentheses, and then plus 4.09. So for this one, we're going to use order of operations, and we're going to do the parentheses part first. So let's go ahead and do 6.2 minus 1.8. So for this one, we're doing 6.2 minus 1.8. We can't do 2 minus 8, so we have to borrow. So we have a 5 here, and we put the 1 here. 12 minus 8 is 4. We bring down the decimal, and then 5 minus 1 is 4. So now we could simplify this to, I'll write this over here, 4.4 plus 4.09. So now I'll work this part off to the side. So 4.4 plus 4.09. And when you have a situation like this where there's not enough places after the decimal that we could add, you could go ahead and put a 0 like this as a placeholder. So now we could do 0 plus 9 is 9, 4 plus 0 is 4, and then we bring down the decimal, and then we have 4 plus 4 is 8. Okay, so our final answer here is going to be 8.49. Question 3, we have 12.5 divided by 2.5 and then plus 3. So with order of operations here, we're going to look at the two operations happening, and we have division and we have addition. So in this case here, we're going to do the division first. So first we're going to do 12.5 divided by 2.5. And for this one, remember, we could use the big idea from earlier that when we're dividing decimals, we want the divisor to be a whole number, so we could move the decimal one space to the right. But if we go one space to the right, so we move over one place, then we have to do the same thing over here. So we could rewrite this as 125 divided by 25. And 25 goes into 125 5 times. 5 times 25 is 125. You subtract and you have no remainder. So this part here I could work out is going to simplify to, we're going to have 5 and then the plus 3 at the end. So now we just simplify this. 5 plus 3 is 8, and that's our solution to 3. Question 4, we're going to use order of operations again, and this time we're dealing with parentheses. So we have parentheses over here, and then we have multiplication and subtraction. So with this one, we just have to be very careful. So I know we are dealing with multiplication and subtraction. However, the subtraction is inside parentheses. So we're going to do the subtraction first because it's inside the parentheses. So even though we are dealing with subtraction, the subtraction here is not truly behaving the way it does when we have this order of operations set up because it's inside the parentheses. So right away, it outranks multiplication. So let's go ahead and do the subtraction inside the parentheses first. So we could do 3.2 minus 1.7. And for this, we'll borrow. So we put a 2 here and a 1 here, and 12 minus 7 is 5. Bring down the decimal, 2 minus 1 is 1. So what we have next, we could say this is equal to 5.6 times the parenthesis part simplified to 1.5. So now we could go ahead and multiply this out. So we're going to do 5.6 times 1.5. And for this, notice after the decimal, we have 2 digits. We have 1 here and 1 here. So we have to pay back at the end 2 places. Okay, so just remember we have to pay back 2 places. So we're going to do 5 times 6 is 30. Carry the 3. 5 times 5 is 25, plus 3 is 28. We put a placeholder here, and now we do 1 times 6 is 6. 1 times 5 is 5. We add, and then 0 plus 0 is 0. 8 plus 6 is 14. Carry the 1. And then 1 plus 2 plus 5 is going to give us 8. So we're going to get not 840. We have to pay back 2 decimal places. So I put my decimal here, and I'm going to move this 2 spaces to the left. So we go 1, 2. And the solution here is going to be 8.4. Okay, so we're going to get 8.4. Now remember, let's say with this part over here, I talked about checking if your answer is reasonable. So what you could do with that is think about, let's say I did 5 times 1. So 5 times 1, see, I would be making the first number smaller and the second number smaller would be equal to 5. And now let's say I round up. So 6 is greater than 5.6 times 2 is greater than 1.5. 6 times 2 is 12. I know that our answer has to be between 5 and 12. So that's why 8.4 is the only reasonable choice here for where to place the decimal, because any other placement of the decimal would result in a number that's not between 5 and 12. Okay, so these are just little mental checks you could do to check to see if your answer is reasonable. So our solution to 4 is 8.4. Question 5, we're doing order of operations again. And this time we're dealing with, we have parentheses, and then we have division, and we have addition. Okay, inside the parentheses is subtraction, but since it's inside the parentheses, we're just going to do that first. So we're going to do 8.4 minus 2.9. And for this one, we can't do 4 minus 9 because 9 is greater than 4. So we borrow, so we have a 7. We put the 1 here. 14 minus 9 is 5. Bring down the decimal. 7 minus 2 is 5. So now I could say this equals, we're going to have 5.5, and now divided by 0.5, and then plus 6.3. So now we took care of the parentheses. There's only division and addition left, and division outranks addition. So we're going to do the division next. So we're going to do 5.5 divided by 0.5. And for this one, we could just use our division concept here. So let's move this over. So we could move the decimal place 1 to the right for the divisor, and that way we're dividing by a whole number. And that means we're going to move the decimal 1 place to the right for our dividend here. So we're going to have 55 divided by 5. And 5 goes into 55 11 times. Okay, so this part here in the next line I could say is equal to 11. And then we have plus 6.3. And for this one, I could write this out as 11.0 plus 6.3. And then I'm doing 0 plus 3 is 3. Bring down the decimal. 1 plus 6 is 7. And bring down the 1. So we get as the final answer here 17.3. Question 6, an incomplete equation is shown below, and we have negative 5.4 plus 3.9 plus blank equals 0. And we want to know which expression, when placed in the blank, makes this equation true. So for this one, we're going to start off by doing negative 5.4 plus 3.9. And I just want to point out the concept here. So when you're dealing with negative numbers, the concept that I want to go over is if I do something like 7 minus 5, I get 2. But if I switch the order and do 5 minus 7, that's equal to negative 2. So when I do negative 5.4 plus 3.9, I could, off to the side, do 5.4 minus 3.9, and I get a positive number. But then when I do this one, I'm just going to take the opposite of this number. Okay, so that's the concept that I'm using when I look at this simple question involving integers. So here I'm going to borrow, make a 4, and put the 1 here. 14 minus 9 is 5. Bring down the decimal. And then 4 minus 3 is 1. So this expression over here is going to equal negative 1.5. Okay, so once again, I'm just using this concept here to get whatever the sum is. So now I want to know negative 1.5 plus how much equals 0. Well, whatever goes here, so this value over here, has to equal positive 1.5, because the only way to make this number go to 0 with addition is to add the opposite to it. So I would do negative 1.5 plus 1.5. So what I'm thinking as I go through the answer choices is I want to find a pair of numbers such that when I add them, I get positive 1.5. So I know this one is out right away, because that, when I do the math in my head, if I'm doing 2.4 plus 0.3, that gives us 2.7. I just think of that as 3 plus 24 is 27, and then I put the decimal in. And now this one over here, I'm just looking at choice C is no good, because if I were to do 3.6 and minus 1.8, 3.6 minus 1.8, if I borrow here and make a 2, 16 minus 8 is 8, 2 minus 1 is 1, we get 1.8, not the 1.5 that we need to cancel this out. Okay, so that's why this answer is out. And then this one here is not looking like it, because if I do 4.2 and minus 2.1 and subtract these, I get 2.1, which doesn't cancel out the negative 1.5. I need 1.5. So just by process of elimination, it has to be choice A. And let's see what we get when we do 6.3 and a minus 4.8. So if we work this out, borrow, get a 5. 13 minus 8 is 5, and 5 minus 4 is 1. We get the 1.5 we need here. That will cancel out the negative 1.5, which is the result of adding these two. So definitely choice A. Question 7, determine the value of the expression shown below. And we have 0.6 times 4 minus 11 all over 0.8. So in terms of order of operations here, what we have going on is we have parentheses, and then we have multiplication. We're multiplying 0.6 by 4 minus 11. And then over means divide. Okay, so when you have a fraction bar like this, that tells you to divide by the number on bottom. So we have parentheses, multiplication, and division. So let's go ahead and follow this order of operations, and we'll do 4 minus 11 first. So if I do 4 minus 11, well, for this one, I know that 11 minus 4 is equal to 7. So 4 minus 11 would be negative 7. So this expression over here, I could write as 0.6 times negative 7 and all over 0.8. So next what I could do, and I'll just make this a little neater, is I could do 0.6 times negative 7. Well, for that one, if I do 7 times 0.6, let me just write this a little nicer. So I have 7 times 0.6. For this one, it's like doing 7 times 6 is 42, and then I just throw the decimal in the middle like this. Okay, so this part here, I would get 4.2, but since I'm doing 0.6 times negative 7, a positive times a negative is negative, I get negative 4.2 over, and then I get 0.8. So now for this, when I divide off to the side, what I'm going to do is I'm going to do 0.8 going into 4.2. And for this one, I would move the decimal one place. So I go one place here, and I go one place here. And that would tell me to do 42 divided by 8. And now when I do this, 42 divided by 8, I could get as close as 5 times 8, which is 40. I subtract, I have a remainder of 2, but I'm originally, let me just make that neater, I'm originally dividing by 8. So this I could simplify to 5 and 1/4. But if I want to express 1/4 as a decimal, I could do 1 divided by 4, but there's a clever way to get there. So what I could do is I could take 1/4, so I'll do this over here, and I could take this fraction and multiply by 25 over 25, and this makes 25 over 100. Okay, so 1/4 is equal to 0.25, 25 hundredths. So this I could say is equal to 5.25. So this quotient here, I have a negative divided by a positive. This is going to come out to negative 5.25. Okay, so I could just write it out like this. Now, let's say you didn't notice this trick over here, so I'll just erase this part and show another way to get there. I could take 1/4 and write 1 divided by 4, and I say 4 goes into 1 0 times, and then I throw a decimal. Well, I would throw my decimal up here and then just start adding zeros. Okay, so here I would have an extra 0 and say, all right, 4 goes into 10 2 times. 2 times 4 is 8. Subtract remainder 2, and then I'm allowed to throw extra zeros after the decimal. I bring this down. 20 divided by 4 is 5, and it divides evenly, and we get no remainder. So 1/4 I could turn into a decimal using this method here. So for this one, I'm going to have negative 5.25. So what I'm about to show is just something extra. So for this, let's say I take the same question here and I do 0.6 over 0.8. That's the same thing if I go times 10 times 10. So this math I would do in my head, but just to show where it's coming from would give us 6/8. And then here I divide top and bottom by 2, and this is more mental math that I'm doing, and that gives us 3/4. So this piece over here, the 0.6 over 0.8, I could express as 3/4. And now I'll just make a little bit more space. So then what I'm doing is I'm taking 3/4 and I'm multiplying that by 4 minus 11 is negative 7. So I'll just say 3/4 times negative 7. And then 3 times negative 7 is negative 21. And I'm over 4. And then I say 21. So I have a minus 21 divided by 4. 4 goes into 21 5 times with a remainder of 1 over 4. And then negative 5 and 1/4 is also equal to negative 5.25. I just wanted to review the decimal operations from this whole, set of questions that I assigned, but just if I could do this any way I want, I would involve fractions as well. So now we're moving on to section 6, the multi-step word problems. And the big idea for this section is to choose the operation based on the situation. We're either going to combine, compare, repeat groups, or split into equal parts. Question 1, we have a taxi charges $3.50 plus $1.25 per mile. And we want to know how much does a 4-mile ride cost. So for this one, we have to think about what these prices represent. So the $3.50 is the fixed cost. So this is just how much it costs to get into this taxi. And then the $1.25 per mile represents the rate, which is how much the taxi driver is charging per mile. So if we want to know how much does a 4-mile ride cost, we have to consider how to build up the total bill here, or the total price of this ride. So it's $3.50 just to get into this taxi. And then if we're going 4 miles, we're going to be charged $1.25 4 times. Okay, so for each mile, we're getting charged $1.25. Okay, so this is for the first, second, third, fourth mile. But repeated addition we could replace with multiplication. So we could do $3.50 plus $1.25 times 4. And now we think back to the last section here. We're going to use order of operations. So we think about what we have here. In the order of operations, we have multiplication. So notice here we have multiplication and we have addition. Okay, and I'll do this in a different color. We have addition happening also in this expression. So we're going to do the multiplication first. So off to the side, what I'm going to do is I'm going to do 1.25 times 4. And I want to point out that we have 2 digits after the decimal. Okay, so we have a 2 and a 5 after the decimal. So at the end, we're going to have to pay back 2 places. Okay, so let's just think here. We have to pay back 2 decimal places. Okay, so that's something we have to be mindful of at the end. So 4 times 5 is 20. We put a 0, carry the 2. 4 times 2 is 8. 8 plus 2 is 10. So we put a 0, carry the 1. 4 times 1 is 4, plus 1 is 5. And we're going to pay back, once again, 2 decimal places. So we have 500, but we're going to move this to the left 1, 2, and that's going to give us 5. So that's the product of 1.25 and 4. We're going to get 5. So in the next line, we have 3. So let's write the decimal in. We have 3.50 plus 5.00. And now we're adding these two numbers together. So I'll do this off to the side. So what we're going to have over here, we're going to do 5.00 and then plus 3.50. And for this, we're just going to do, let's make this a little neater. 0 plus 0 is 0. 0 plus 5 is 5. Bring down the decimal. 5 plus 3 is 8. And this tells us the total bill is going to be $8.50. So I'll just write that over here. We have the total cost of the trip is $8.50. Question 2, a board is 12.5 meters long. Maya cuts off 3.75 meters, then another 2.8 meters. How much is left? So in this question here, the phrase cuts off tells us to subtract. And then after this, we have Maya cuts off 3.75 meters, then another 2.8 meters. So this phrase is telling us to subtract 2.8 as well. And I'll just make this a little neater. So we're going to be subtracting twice. So the actual expression we need to simplify is 12.5 minus 3.75 and then minus another 2.8. And since we're only dealing with subtraction here, we could just move from left to right. So first, we could do 12.5 minus 3.75. And notice there's no digit above the 5, so we could put a 0 in as a placeholder. And now we start the process. So I'm going to borrow here, so we could turn this 5 into a 4 and move the 1 over. 10 minus 5 is 5. We can't do 4 minus 7 because 7 is greater than 4. So we borrow here to turn this into 11, and we move a 1 over here. 14 minus 7 is 7. Bring down the decimal, and now we're doing 11 minus 3 is 8. So we could write this now as 8.75 minus 2.8. And now we'll do this part off to the side. So we're going to subtract these two values here. So we could do 8.75, and we're subtracting 2.8, which I'll write as 2.80 to put a placeholder here. And now we have 5 minus 0 is 5. We can't do 7 minus 8 because 8 is greater than 7. So we borrow, we put a 1 over here. 17 minus 8 is 9. Bring down the decimal. 7 minus 2 is 5. Okay, so this works out to 5.95. But how much is left? We'll write the units with it. We'll say 5.95, and the units here are meters. So this is our solution. Question 3, a runner trains 2.6 miles on Monday, 3.75 miles on Tuesday, and 4.25 miles on Wednesday. How many miles total? So for this one, we're just going to add these three values up. So we're going to do 2.6, and we're going to add 3.75, and then we're going to add 4.25. And this we could just do all at once. Okay, when you're adding a bunch of numbers, you could line them all up at once. I'm just going to put a 0 here as a placeholder. So first we do 5 plus 5 is 10. So we have a 0, carry the 1. 1 plus 6 is 7. 7 plus 7 is 14. And 14 plus 2 is 16. So we have a 6, carry the 1. 1 plus 2 is 3. 3 plus 3 is 6. 6 plus 4 is 10. So I have a 10 here, and I'm just going to bring down the decimal here. Okay, the decimal is lined up nicely like this. So we're going to have 10.60. But this 0 is just a placeholder here. So at the end, I could say 10.6 miles. That's the number of miles that the runner trained. Question 4, a $45.80 bill has a service fee of $2.35 added and then a $5 coupon subtracted. What is the final cost? So for this one, what we're going to do first is we're going to take this bill and we're going to add $2.35 to it. Okay, so we're going to take the $45.80. So we have this, and we're going to add the $2.35. Okay, so this is going to be added. We have 0 plus 5 is 5. 8 plus 3 is 11. So we put the 1 here and carry the 1 up. Decimal comes down. 1 plus 5 is 6. 6 plus 2 is 8. And then the 4 just carries down like this. Okay, so this is the new total for now. But then the $5 coupon is subtracted from the total. Okay, when a coupon is applied, that saves money. So we're going to subtract $5. Okay, so we take the $48. Let's just make this neater. So we have the $48.15, and we subtract $5. So I'll just say minus, and then $5. We're going to have a 5 here in the ones place, and then 0, 0 in the tenths and the hundredths. So now we do 5 minus 0 is 5. 1 minus 0 is 1. Bring down the decimal. And now we're doing 8 minus 5 is 3. And the 4 just carries down. So we have $43.15. That is the final cost. Question 5. Imani makes and sells scented candles. She buys 18 ounces of wax at a price of 85 cents per ounce. Each candle requires 2.25 ounces of wax, and Imani uses all of the wax. She sells each candle for $6.50. What is the total profit Imani makes after buying the wax and selling all the candles? So for this question, we're looking for the total profit. And I just want to point out here that the profit is equal to the money that Imani makes, so the money made, minus the cost. Okay, and this is how much it cost for Imani to make all of these scented candles. So if we look in the question here, we're told that Imani buys 18 ounces of wax at a price of 85 cents per ounce. So for this one, if we want to find the cost, that's what's showing up first in the question. We're going to multiply 18 by 0.85. Okay, so we're going to do 18 times 0.85. And for this one, notice we have a decimal here, and we have 2 digits to the right of the decimal. And I'll just move this up a little bit so we have more space. So at the end of this multiplication here, we have 2 decimal places that we're going to have to pay back. Okay, so we have 2 decimal places to account for. So we're doing 5 times 8 is 40. So we have a 0, carry the 4. 5 times 1 is 5, plus 4 is 9. And now we go to the next row here. I'll cross off the 4 from before so we don't get distracted. Then we have 8 times 8 is 64. So we put down the 4. I'll just make that neater. So we have a 4, and then we have the leftover 6 up here. And then we have 8 times 1 is 8, plus 6 is 14. And now we just add the stuff up. So 0 plus 0 is 0. 9 plus 4 is 13. We carry the 1. 1 plus 4 is 5. And then we have this 1 just carrying down here. And we have to pay back 2 decimal places. So this tells us that Imani is going to spend $15.30 to make the candles. But now we have to calculate how much money does Imani make from selling all of the candles. Well, they tell us each candle, so each one requires 2.25 ounces of wax. So if we think about this, Imani is going to buy 18 ounces. So she's buying 18 ounces, and each candle requires 2.25 ounces. So we need to do 2.25 dividing into 18. And for this one, there's a few different ways we could handle this. But remember, the big idea from earlier is we want to move the decimal a certain amount of places so that we have a whole number outside that we're dividing by. So we're going to divide by 225 instead, but I can't just move this decimal 2 places and hope no one notices. I'm going to put 18.00, and I have to move this decimal 2 places. So what I'm really doing over here is I'm doing 1,800 divided by 225. Now, if I'm doing this without a calculator, I'll show you some of the mental math that I'm doing to help me estimate so I could get within a reasonable distance of 1,800. So first, I think of 225 times 10. So 225 times 10 would give us 2,250, which would go too far. But then I think about it, if I were to subtract 225, I would still be more than 2,000. So I'm going to have to go even less than that. So let's see what happens if I do 225 times 8. So if I do 225 times 8, let's see where that gets us. So you have 8 times 5 is 40. So we have a 0, carry the 4. Then we have 8 times 2 is 16 plus 4 is 20. So 0, carry the 2. And then we have 8 times 2 is 16 plus 2 is exactly 1,800. Okay, so that tells us the mystery value here is going to be 8. And when we multiply, we get exactly 1,800. And this is what's going to work out. So once again, the math I was doing in my head was I did 225 times 10. And then I just, in my head or off to the side, subtract 225 to see how close that gets us. And if we were to do this, work this out, this would give us, we would have an extra, when we work this out, 2,025. Okay, so if I just subtract here, 2 minus 2 is 0, the extra 2 carries down. And you see how 2,025, this would equal 225 times 9 if I subtract 225 from this quantity here. And that would still be too much. So I was like, oh, let me try 225 times 8. And then that brought us exactly there. Okay, so that's just some estimation strategies you could use in your head to help you get to where you need to go. Okay, so this is going to help us out to move to the next stage of the question, because what this tells us, if each candle requires $2.25 ounces of wax, then Imani could make 8 candles. Okay, so this is going to be, we're going to have 8 candles total here. So that's the maximum amount of candles that Imani could make with all of the wax that she bought. So now what we're going to do from here, they tell us that she sells each candle for $6.50. So the last bit of math we're going to do is we're going to take $6.50 and we're going to multiply by 8. Okay, well, this is the last bit of math we need to do to find out how much how much Imani will make. We already know this is going to cost her $15.30, but we want to see how much money she'll actually make from the candles. So we have 8 times 0 is 0, and then we have 8 times 5 is 40, so 0, carry the 4. And then we have 8 times 6 is 48, plus 4 is 52. And notice that I ignored 2 decimal places, so I would move the decimal 2 spaces this way, and this would give us exactly $52. So now we have enough information to find the total profit. So for the total profit here, we just have to think about how much money does Imani make selling all 8 candles? She makes $52. So we take the $52 that she'll make, but we have to subtract how much it cost to make all the candles, and that's going to cost $15.30. Okay, so minus $15.30. So here we can do 0 minus 0 is 0, but we can't do 0 minus 3. So we borrow, we make this a 1, and we move 1 over. And we have 10 minus 3 is 7. Bring down the decimal, and now we borrow from here. So we have a 4, put a 1. 11 minus 5 is 6, and 4 minus 1 is 3. So Imani's profit is going to be $36.70. So now we're moving on to section 7, and we're going to convert from fractions to decimals, and we're going to convert from decimals to fractions. And the big idea for this section is convert fractions to decimals by dividing the numerator by the denominator, and then convert decimals to fractions by reading the place value. For the first question, we're going to write 3 over 10 as a decimal. And for this one, when you read 3 over 10, you could say 3/10. Okay, so 3/10. When I hear that, I think of writing a 3 in the tenths place. Okay, so this we could express as 0.3, and this would be the same value as the fraction 3 over 10. Question 2, we're going to write 7 over 1,000 as a decimal. Well, for this one, 7 over 1,000 is the same thing as 7 thousandths. Okay, so that is a 7 in the thousandths place. So for this one, I'm going to write out 0.007. Question 3, we're going to convert 0.45 to a fraction in simplest form. Well, first, we should read this as 45 hundredths. So this we could write as 45 over 100. But the question told us to write this in simplest form. So if we stop here, we're not fully answering the question. Now, I noticed that the last digit in the numerator and denominator, we have a 5 and a 0. So I know that these two numbers are divisible by 5. So I'm going to divide the numerator by 5 and the denominator by 5. And if I do 45 divided by 5, I get 9 over 100 divided by 5 gives us 20. Okay, so this fraction in simplest form is 9 over 20. And I know that we can't simplify anymore because if I think about this, the factors of 9, so 9, I think of the factors are just 1, 3, and 9. Okay, we have 1 times 9 and 3 times 3. Whereas 20 has a bunch of factors, has 1, 2, 4, 5, 10, and 20. But notice they have no other common factors other than 1. So we can't reduce this fraction anymore. Question 4, we're going to convert 1.375 to a fraction in simplest form. So if I want to express this decimal as a fraction, first what I could do is I could just write this decimal 1.375 as this value here over 1. And if I want to turn this into a fraction in simplest form, I want to get rid of the decimal in this question. So I notice there's 3 digits to the right of the decimal. So I would multiply by 1,000, which is a 1 with 3 zeros. And another way to see this is we're going out to the thousandths place. So by multiplying by 1,000, that'll move the decimal all the way to the right and turn this into a whole number. But if I multiply the numerator by 1,000, I'm going to have to multiply the denominator by 1,000 as well. So if I multiply the top by 1,000, the decimal goes 1, 2, 3 to the right, and we get 1,375, and we're over 1,000. So for this, we need to write the fraction in simplest form. So now I'll start reducing. Now, when I think about the multiples of 25, 25, if we start counting by it, we get 25, 50, 75, 100, and then we get 125, 150. And you might notice the pattern here. The multiples of 25 either end in 25, 50, 75, or 2 zeros. So I know that these two numbers are divisible by 25. They also happen to be divisible by 125, but it's less obvious that they are, and it's probably easier here to start by dividing by 25 first. So I'm going to divide the numerator and denominator by 25, and I'll do that long division on the side. So first we're going to do 1,375, and I'll just make this a little neater. So we have 1,375, and we're dividing that by 25. So here I could say that 137 divided by 25 is going to equal 5. Okay, so this is going to go in 5 times. And now I do 5 times 25, and 5 times 25 is 125. So I subtract. 7 minus 5 is 2. 3 minus 2 is 1. And then I bring down the 5. 125 divided by 25 is 5. 5 times 25 is 125. And I get no remainder. Okay, so far this is going to equal on top. We're going to have 55. Okay, so 55 times 25 would bring us back to this. But now when I divide this part, so I'm going to do 1,000 divided by 25. Well, for this one, we just divide this out, and 25 goes into 100 4 times, and we get 4 times 25 is 100. We subtract, we get a 0. We bring down the last 0, and 0 divided by 25 is 0. 0 times 25 is 0. We subtract, and we have no remainder. So we're going to get 55 over 40. But now for this one, I just divide by 5 one more time. Both of these numbers are divisible by 5. So I divide both of these by 5. So I'm going to divide the top and bottom by 5. And now this will simplify to on top 11 over the denominator becomes 8. And this is simplest form. 11, the only factors are 1 and 11. And then 8 is divisible by 1, 2, and 8. And they have no more common factors other than 1. So this is as reduced as possible. Question 5, 2 students are comparing the numbers 3/8 and 0.4. Jamal says 3/8 is greater. Aaliyah says 0.4 is greater. Who is correct? Explain your reasoning. So for this one, what we could do first is we could take the fraction 3 over 8 and turn it into a decimal. So 3 over 8 means 3 divided by 8. And for this one, the closest we could get to 3 is 8 times 0. If we did 1 over here, 1 times 8 is 8, which is more than 3. So then what we do here is we put a decimal and a 0, and then we could put the decimal above like this. 0 times 8 is 0. So when we subtract, we have a 3 again, and now we can bring this part down, and we're doing 30 divided by 8. 30 divided by 8, we could get as close as 8 times 3 is 24. When we subtract, we have a remainder of 6, and we can just keep adding zeros after this decimal because 3 is equal to 3.000. I could just keep going with that. So now I bring down the next 0, and I could get as close as 7 times 8 is 56. Okay, if I were to go 8 times 8, that would be 64, and that would go too far. So I have a remainder of 4. I put one more 0, and this is the last one I need because 40 divided by 8 is exactly 5. 5 times 8 is 40. We subtract, we have no remainder. So what this tells us, we could say 3/8 is equal to 0.375. So this was the value that Jamal was talking about. And Aaliyah, so we look at Aaliyah's value here. So I'll write it over here. So we have Aaliyah is siding with the number 0.4. Okay, so Aaliyah says 0.4 is greater. So when you compare these two numbers here, the thought process is you just want to think about if you were to put extra zeros at the end, you're comparing 0.375 and 0.400. So just imagine you're comparing 375 to 400. This number here is greater. Okay, so 0.4 is going to be greater than 3/8. So if I had to explain my reasoning, I would say first, Aaliyah is correct. So let's just write this out here. So we have Aaliyah is correct. And why is she correct? So we have to write a because. Anytime you hear the word explain in math, you have to attach a because and put a reason. Okay, so Aaliyah is correct because we could say here 3/8 equals 0.375 and 0.4 is greater than 0.375. Okay, so turning the fraction into a decimal makes it very definitive that Aaliyah is correct. Question 6, we're going to use long division to express 59 over 400 as a decimal. So for this one, we're doing 59 divided by 400. And notice that 59 is less than 400. So in a situation like this, we could get as close as 0 times 400. And when this happens, what you want to do is you want to put a decimal and then a 0, but then you're going to put a decimal right above like this. So now we could say 400 goes into 590 one time. And 1 times 400 is 400. And we subtract, and we have 0 minus 0 is 0, 9 minus 0 is 9, and we have 5 minus 4 is 1. And I could just keep adding zeros like this until I either see a pattern or this decimal terminates above. So I bring down the 0 like this. So I have 1900 divided by 400. And for this one, I imagine that I'm counting by 4s. Okay, so I imagine let's say I count by 4s. I have 4, and then 8, 12, 16, 20. So if I want to count by 400s, I know I'm going to have, let's say 400, then 800, then 1200, then 1600, then 2000. Okay, so I could get as close as 1600, but if I go one more, I'm going to go to 2000, which goes past. So I could put a 4 here and say 4 times 400 is 1600, and I subtract, and I have a remainder of 300. Now I put one more 0 and bring it down, and for this one here, I could get as close as 400 times 7. Just think of doing 7 times 4 is 28, and then we have 2 extra zeros at the end. So we subtract here, we have a remainder of 200, and now this is going to be the one. I put one more 0 down here, and 2000 divided by 400. So the math I'm doing in my head when I divide 2000 by 400, you can just see the zeros crossing off at the end. You could cross off common zeros, and 20 divided by 4 is equal to 5. So I get a 5 at the end. 5 times 400 is 2000, and when we subtract, we have no remainder. Okay, this divides evenly. So we could say our decimal here, our final answer, is going to be 0.1475. And now last, we have section 8, repeating decimals and rational numbers. The big idea for this section is that repeating decimals are just fractions in disguise. Any decimal that ends or repeats is a rational number. And for question 1, we're going to write 0.333 repeating as a fraction. So if you have the same digit just showing up after the decimal, what you could do is you could take that digit and write it over 9. Okay, so 9 is the culprit anytime you have a repeating decimal like this. So 3 over 9 is equal to 0.3 repeating. And I'll write this also in simplest form. So I'm going to divide numerator and denominator by 3. And this is going to work out to 1/3. Okay, so 1/3 is going to be our answer. If we want to check our answer to this, we could use the technique that we went over in the previous section. So I could take 1 and I could divide it by 3. And I would say 3 goes into 1 0 times, and then I write 0.0 at the end, and I put a decimal up here. 0 times 3 is 0. I subtract, I get 1, I bring down the 0. 3 goes into 10 3 times. 3 times 3 is 9. I subtract, remainder 1. And notice that I just keep getting 10 over and over. 10 divided by 3, I could get as close as 3 times 3 is 9. So I subtract that, I get remainder 1, and this pattern is going to continue on and on forever. So I'll get 0.3 repeating. Now, just in case we haven't seen this notation before, when you put a bar above the numbers after the decimal, that just means those digits repeat forever. Question 2, we want to convert 0.6262 repeating to a fraction. So notice that the pattern is 2 digits, okay? So this is a 2-digit pattern. So when you have a 2-digit pattern like this, what you want to do is you want to write the 2 digits over, and now I put 2 9s on bottom. So I'm going to have 62 over 99. So this is going to be our fraction. And now for our last question, we're going to convert 0.007007 repeating to a fraction. And this is a 3-digit pattern, okay? 007 is repeating forever and ever. So here, I'm just going to write the 7. However, since this is a 3-digit pattern, I'm going to put 3 9s on bottom like this, okay? And this is going to be our fraction for this infinite decimal here. Now, another thing to point out, let's say instead I had 0.07 repeating like this. So let's say that were the pattern. Then I would say that this is equal to 7 over, and then I put 2 9s like this, okay? So when there's 2 zeros and then a 7, I would put 3 9s like this. Now, a fun thing about this concept for the last section is if I have something like, let's say, 0.9 repeating, okay? So just 0.999 forever and ever like this. This I could say is equal to, we have a 9 repeating, and this is a 1-digit pattern, so I'd have 9 over 9. And this tells us, well, 9 divided by 9 equals 1. So this tells us that 0.9 repeating is actually equal to 1.